Notice that the word ratio is in the word rational. A rational number is any number that can be written as a ratio of two integers, such as a over b, where b is not 0. Another way to say this is that a rational number is any number which can be written as a fraction. Some examples of rational numbers include positive and negative whole numbers like 12, which can be written as a fraction with 1 in the denominator. Repeating decimals like 0.1 repeating, which can be converted to the fraction 1/9, and terminating decimals like negative 10 and 25 hundredths, which can be written as the improper fraction negative 41 over 4. The square root of perfect squares are also rational because when evaluated, the answer is a whole number, which can always be written as a fraction. For example, the square root of 16 is 4, which can be written as 4 over 1. So if positive and negative whole numbers and decimals that terminate or repeat can be written as fractions, what kind of numbers cannot be written as a fraction? Pi is a number which cannot be written as a fraction. The decimal expansion of pi is 3.1415926, and it goes on forever and doesn't repeat. Pi is an example of an irrational number. An irrational number is a number which cannot be written as a fraction. Some examples of irrational numbers include pi and the square roots of non-perfect squares, like the square root of 7 and the negative square root of 60. So now that we have defined rational and irrational numbers, let's work a few examples. Is 5/8 a rational number? Well, 5/8 is a fraction, so yes, it is a rational number. Example 2. Is the square root of 81 an irrational number? Well, 81 is a perfect square number because 9 times 9 equals 81. So the square root of 81 is 9, which is not an irrational number because it can be written as a fraction, 9 over 1. So no, the square root of 81 is not irrational. Example 3. Which of the following is a rational number? Well, none of these are in fraction form, but that doesn't mean that they can't be rational numbers. Remember, positive and negative whole numbers and decimals that terminate or repeat can also be written as fractions. Well, we know that pi is irrational because its decimal expansion doesn't repeat or terminate. Now, since 62 is a whole number and no whole number times itself equals 62, 62 is not a perfect square, so the square root of 62 is irrational. Negative 59.361 is a terminating decimal, so it is a rational number. And like 62, 33 is not a perfect square, so its square root is irrational. So negative 59.361 is the only rational number here. Let's do one more. Which of the following are irrational numbers? In order for the square root of a whole number to be irrational, the whole number must not be a perfect square, which means that no whole number times itself will equal the number under the square root sign. Well, there is no whole number times itself that equals 39, so the square root of 39 is irrational. The square root of 9 is not irrational because 3 times 3 equals 9. So the square root of 9 is 3, which is a rational number. There is no whole number that will multiply by itself that will equal 23, so the square root of 23 is irrational. And lastly, 5 times 5 equals 25, so the square root of 25 is 5, which is not irrational. So the square root of 39 and the square root of 23 are irrational. Now let's review. A rational number is any number that can be written as a fraction, and that includes positive and negative whole numbers, terminating and repeating decimals, and the square root of perfect squares. An irrational number is a number that cannot be written as a fraction. The decimal expansion of an irrational number never ends or repeats. Examples include pi and the square root of non-perfect squares.